Okay. So today's session, we're going to be looking at inferences about the difference between two population proportions. The previous weeks, we've been looking at the population mean, one where it was matched and one where it was unmatched. I think the next session, which will not be next week, I think it will be next week. Yes, next week, Tuesday. The next session, we're going to cover the inference about the variance. And then we will do also the ANOVA. I will have to check the schedule as well. Okay, so what I planned was to first cover the hypothesis testing in the first hour, and then in the second hour, we will do the confidence intervals or the interval estimations. And we will see how it goes. If we finish early, we can look at other extra exercises as well. So since we're going to be looking at hypothesis testing, and we're going to look at for the difference between two population proportion. So at the end of the 1 hour, you should learn or know how to conduct a hypothesis testing. And remember, last week, I think that's where, or the previous week, we started introducing the 6 steps of hypothesis. It's very important that you know and understand these 6 steps, because every time you do a hypothesis or you're going to answer a question in the exam or in your assignment, sorry, I need to put this in the presentation mode. I apologize for that. So when you answer the questions in the exam, you will realize that all the options as your answers, whether you are looking for the correct or incorrect answer, all the options are related to the 6 steps. So you will have to know all the 6 steps in order for you to be able to answer the questions as well. So just to refresh your mind again, the step number 1 is to state the null hypothesis and the alternative hypothesis. This is very important because it tells you what the researcher wants to prove, and it also guides us in terms of when we look at the alternative hypothesis side, whether we're doing a one-tailed test or are we doing a one-tailed test. Then you also need to know what you are given in terms of the alpha. Remember, if they didn't give you alpha, which is your level of significance, then it means they give you confidence interval or confidence level, which is 1 minus alpha, and then you can calculate the level of significance from there. And also in relation to the sample size. Remember now, because we're working with 2 populations, therefore you will have 2 sample sizes, sample size N1 and sample size N2. Then you also need to know what kind of a test are you doing, because based on the statement, for example, now we're going to be doing the proportion. All questions or calculations that you do on the proportion, you need to know what kind of a test is it. Is it the F test? Is it the T test? Or is it a Z test? So in terms of the hypothesis testing for the proportion, we're always going to use the Z test. So you need to know that, the appropriate test statistic that you're going to be doing. Also, since you know what kind of a test are you going to be doing, it's going to be easy to find the critical value, because for every test statistic, the critical value is different because you use different tables. For example, the previous times we were using the t-test table. So we went to the t-table. This week, we're going to introduce a new table, which is the Z table, or the cumulative standardized normal distribution table, which is, it has the Z scores and it has your values of your probabilities inside. And the probabilities inside the table are what we call the level of significance, but also depending also on your alpha and depending on your hypothesis testing, in your alternative hypothesis testing, whether you're doing a one-tailed test or a two-tailed test, you also need to know whether are you going to divide your alpha by 2 in order for you to find the critical value. With this one, we don't have to use the degrees of freedom. It's only, you're going to only use your value of your alpha. And it also helps because it's also going to tell you where your region of rejection is. And when you do the conclusion, you will know where you need to, whether are you rejecting or you do not reject your null hypothesis. Then step number 5 is for you to calculate the test statistic. So since we're going to be using the Z, you need to know the formula for the Z test in terms of your hypothesis testing. Then the last step will be for you to make a decision. And making a decision, it means you're going to use your critical value plus your Z test and see where they lie, whether your Z statistics lies in the rejection area or in the do not reject area. And then after that, you're going to make your conclusion in relation to your hypothesis testing. Okay, so let's look at how we do the hypothesis testing for 2 proportions. So the goal for this is to test the hypothesis for the difference between the 2 population proportions. So since we have 2 populations, so we will have population 1 and population 2. So we want to check if there is any difference between the 2 populations. The assumptions are the population sample size, the sample size and your population should be more than 5, and your standard deviation or your variance of that should be more than 5 as well. And for the point estimate, which is the value we use to estimate our population proportion, we're going to be using P-GAPI, and we're going to use the difference between the sample proportion. And for our sample proportion, our P1, sample proportion P1, sample proportion P1 is given by, so to calculate the P1 GAPI, which is the sample proportion, you will need the observation that satisfy that sample from the sample 1 divided by the sample 1. So you will be given the X value and you will know what your sample size is, and then you can calculate your sample proportion. And for 2 as well, it will be the observation satisfying that sample divided by the sample 2. And that will give you your sample proportion. So if they don't give you the sample proportion in the question, they will give you the observation that satisfy each of those 2 samples so that you can calculate your sample proportion. And when we calculate the test statistic for the population proportion, we also part of the formula for the test statistic, which looks like this, which gives you the test statistic of your sample proportion minus your population proportion difference divided by the standard error, which is your pooled variance times 1 minus your is the pooled variance of the proportion times 1 over the sample 1 plus 1 over the sample 2. And that you need to calculate it outside. You will have to calculate this pool estimate before you calculate your Z, because then the formula for pooled variance is your X1 plus your X2 divided by N1 plus N2. So your observations from your sample proportion 1 or from your sample 1 plus your observation from your sample 2 divided by your sample size 1 plus your sample size 2. And once you have calculated that, you can just come to the formula and substitute it into the formula, and which will be just to substitute into that. And you will have one, instead of having your P copy there, you will have your answer. You will have your answer there, because then you will need to calculate it separately. So now let's look at how we do the hypothesis testing. Remember the 6 steps? So before we look at the 6 steps as well, when we go find the critical value, which I will show you just now how to find the critical value. So to make a decision based on the critical value, so when you go and find the critical value, so if you're doing a one-tailed test where it will say the hypothesis, your null hypothesis will say the population difference is population difference of population 1 and population 2 is equals to 0. Your alternative, if in your alternative or your researcher said they want to test whether something is less than, then it means it will go into your alternative, and it will also demonstrate that you're going to be doing a one-tailed test, and therefore it means you're also going to have one side of your region of rejection. And since it's less than, it will be in the negative side of things, or it will be in the less than side of things. And if your test statistics, when you calculate it and you find it falls in the shaded blue area, you reject the null hypothesis. If it falls in the shaded white area, you do not reject the null hypothesis. For a two-tailed test, for a one-tailed test as well, the upper tail area, so your alternative will state that it is greater than, maybe they will say it is greater than, they find out that the difference between the populations are greater than. So it means you are going to use the greater than sign, and it means your region of rejection will be in the upper tail area, and anything that falls in the blue shaded area you reject. Anything that falls in the white area you do not reject, because then your test statistic will be less than your critical value. You do not reject. For a two-tailed test, you will have two sides of your rejection area, the less than side and the greater than side as well. So it means once you calculate your z-test, and if your z-test falls in the negative side of the area, you reject it. You reject. If it falls in the positive side of the shaded area, you reject. And if it falls in between the two and it falls in the white area, you do not reject the null hypothesis. So let's look at an example of how we use this. So if you want to test if there is a significant difference between the proportion of men and the proportion of women who will vote yes on the proposition A, and we want to test this hypothesis. And in this hypothesis, we selected a random from these two populations, the population of men and the population of women. From this, we selected a random sample of men, which were 36 out of 72. And we know that we selected a random sample of 72 men, and 36 out of them voted yes. And also we selected a random sample of 50, and 31 of those voted yes. If we want to test this at 5% level of significance, then the first step is to state the null hypothesis. Our null hypothesis will state that the difference between the two populations is equals to 0. Because we assume that the two populations are equal. The alternative will say the two populations are not equal, therefore the population difference will not be equals to 0. Step number 2 is to also state what we are given in terms of n, in terms of alpha. We know what our alpha is. Our alpha is 0.05, our n. And we can also just calculate our n, our sample sample proportion because we know what our N is and we know that our X observations are 36 out of 72 for men, which gives us a sample proportion of 50% or 0.5. And for women, we know that the observations, there were 31 of those who voted yes out of 50, which gives us 0.62 or 62% as a proportion of men and women. So now we need to calculate the pooled estimate. Remember, the pooled estimate is that other complex formula that we will need to substitute into the test statistics when we calculate the test statistic. So to calculate the pooled estimate, remember, it is x1 plus x2 divided by n1 plus n2. So we know our x1 was 36 plus 32 divided by 72 plus 50, and we get 76 over 132. And that gives us the pooled estimate of 0.55 or 0.549. Before I move into the test statistics, so the next step, remember, is to find the critical value for the region of rejection. I will do that after I've calculated the test statistic, so that then I don't have to move out of the presentation, because I will need to go and show you on the table where to find the critical value. So I will do the critical value later on. So now we're going to skip critical value and then we go and calculate the test statistic. So calculating the test statistic, the formula, our different sample proportion minus the difference of the population proportion divided by the standard error, which is your pooled estimate, the square root of your pooled estimate times 1 minus the pooled estimate times 1 divided by N1 plus 1 divided by N2. So our sample proportion 1, we calculated it for men, it was 0.5. For female, it was 0.6. We know that the difference between the two is equals to 0. So it's just going to be 0. The square root of our pooled variance, we calculated it, then we found that it was 0.549 times 1 minus 0.549 divided by 1 over 72 for men plus 1 over 50 for females. And when you calculate the whole equation, and you find that it is minus 1.31. And that is our test statistic. So we're going to use the test statistic to go find the critical value, not to find the critical value, to make a decision later on. Now we're going to find the critical value. Finding the critical value, we use alpha. And since this is a two-tailed test, because of a two-tailed test, therefore our critical value of Z will be alpha divided by 2. And we know that we're looking for Z. Our alpha was 0.05 divided by 2, which then gives us Z of 0.025. Just remember that. Remember our alpha, we were given, it was 0.05. And since we're doing a two-tailed test, if we were doing a one-tailed test, we were just going to use the alpha value. And since we're doing a two-tailed test, we have to divide the alpha by 2. And when we divide alpha by 2, we get the value of 0.025. Now we need to go to the Z table. I am going to stop the presenting. I don't know why didn't I share my screen instead of, I'm gonna keep. Okay. going to share. I'm going to show you. So we're now going to go to the Z table. So in your tutorial letter 101, there are tables as well at the back of your tutorial letter. So we're going to look for table. It's called table table 1. Cumulative, standardized, normal probabilities. This is the table we're going to use to find your Z 0,0, 0, 2. Am I putting too many zeros? I'm putting too many zeros. It's 0,025. 250. I'm going to leave it as 4 decimal because I can see your table has 4 decimal. So to find the critical value, because we're looking for the critical value, we need to come to the table. You're always going to find the critical value by using the negative side of the table. The table has 2 sides. There is a positive and the negative side. Later on, we can learn how the positive work. But for the critical value, we're going to use the negative side of the table. So inside the table here, there are those probabilities which are your level of significance, which are, we call them also the probabilities. So inside here are probabilities. So we need to go and look for the probability that reads 0,0250 inside the table. And that probability is here. And since we found that probability, we're going to go out of this table and we're going to go up this table. So we first start with the left side. On the left side, we have 1.9. I'm going to ignore the minus for now and just use 1.9. At the top, we have 0,06. Therefore, if I add both of them, they will end up looking like 1.96 because the last digit of the table is the last digit of your numbers. So you read it 1.96 because at the top you have a 6 and on the side you have 1.9. And this is going to be plus or minus. It's going to be for both. For example, because I am doing the negative side and the positive, because I am doing a two-tailed test. So since it's a two-tailed test, so it will be a plus or a minus. If it was a one-tailed test, if it was a one-tail, when I come here and I find that the probability I'm looking for is 0.25, I will just take, depending on if it's less than, I will take minus 1.96. If it was greater than, I will take positive 1.96. And that's how the table works. So depending on the type of a test you're going to be using, you're going to learn how to interpret the value that you see in front of you. So since this is our critical value, it's plus or minus 1.96. So now I need to, I should share my screen, but I have so many things open on my screen. It's gonna complicate our lives. Okay, so remember we did go find the critical value. We found that it was 1.96, and there is my critical value. Now I'm going to use this critical value to go find out whether am I going to reject this test statistic. So I'm going to draw my graph. Oh, things are moving backwards. So I draw my graph and I put my critical values there. Anything that falls in the shaded blue, I reject. Anything that falls in the shaded blue on the right, I reject. Anything that falls in between, I do not reject. My 131 falls in the shaded, in the white area. Therefore, it means I am not going to reject the null hypothesis, and I can conclude that there is not significant evidence for the difference in the proportion of who will vote yes between men and women. Any questions? If there are no questions, then you have an exercise to do. Consider the following table with the results from the independent samples taken from two populations. And they give you the table with the sample size, the sample proportion, and the number of successes. So here they calculated the sample proportion. You don't have to go ahead and calculate the sample proportion. Then they also ask, they give you additional information, whether there is a difference between two population proportion, use alpha 0.05. That statement probably is for the next exercise that will follow after this, because I took this from the exam paper. Relating to what we have in front of us, the only thing you need to do in here, they are asking you to calculate the test statistic. So to calculate the test statistic, the formula, remember, it is Z is equals to your sample proportion 1 minus your sample proportion 2 divided by the standard error, which is your sample, your pooled estimate times 1 minus your pooled estimate times 1 over N1 plus 1 over N2. And that's all what they're asking you to calculate. And remember, your pooled variance or your pooled estimate, not the variance, but the estimate is given by x1 plus x2 divided by n1 plus n2. When you are done, let me know by just saying you're done, so that I can know how many people are still busy. And if you don't know how to answer the question, please don't just keep quiet, because then we might take 30 minutes while you guys are quiet and not saying anything. If you don't know the answer, just say it. I am stuck, then we can all do it together. How far are you? Are you almost done? Are you guys done?
Yes, I'm done, but I'm getting a complete different number.
You're getting a complete different number.
In terms of the answers provided there, I'm getting something like 84.547.
Did you take the square root of the value underneath the square root? And did you take the square root
Oh,
of
that's why I
the
made a
value?
mistake. Yes, okay, let me quickly fix that.
Thank you. And remember, when you are working out the answers, please keep all the digits, only round off when you get to the final answer. How are we doing?
I'm getting 3.18398, which is, I rounded off to the 3 decimal places, which is 3 point.
Okay, wait. When you were working out your answers, did you round off anywhere?
Yes.
That's the problem. Please do not round off quickly while you're working on your problem. Only round off when you get to the final answer.
Okay.
Next time. So,
okay, it's fine.
the others, how are we doing?
Ma'am,
Yes.
I got the answer, and my answer is 0.0377795. So, from the selection of answers that we have, my answer is almost correct except for the last digit.
How? What? Wait. Okay, sorry. Let's work out this so that you can all see where you going wrong or you are getting it right.
Yeah.
Okay.
Okay.
So
Okay.
the full estimate 192 plus 108 divide by 400 plus 300. What was the answer? 300 divided by 400.
My answer that I got was 0.4285.
0.42857. You must write all the values.
Okay, all the answers.
Yeah.
71428. You must write all of them because when you round off, you might not get the answer. Or when you round off, you must round off correctly as well. Okay. At the top, our sample proportion was 0.48.
1
minus 0.36 divide by the square root of everything underneath. So we take our point estimate. I'm going to cut it short. So I'm only going to use 0.429 in this instance. But when you're doing the calculation, please use all the digits, 0.429 0.429 times 1 minus 0.429 close bracket times 1 over N1 plus 1 over N2. So N1 is, I do not write N1. N1 is 400. And 1 over 300. Did you all get it this way?
Yes.
Yes, I got that as well.
1 minus 0.429, since I'm taking shortcuts as well, just to make sure that you get the same answer, multiply by 0.429 equals 0.244959. Let me write it down. Oh, I don't have to write it down. Multiply that with open bracket. I'm going to open bracket again and say 1 divided by 400, close bracket, plus open bracket, 1 divided by 300, close bracket, close bracket. And so that I multiply with whatever is inside the bracket. Equals, and I get the answer before I take the square root. Did you all get 0.001428927?
Now I got 0.00122. Okay, that's when I rounded.
You round, yes, that's why you rounded off too quickly. So the answer underneath the square root. So at the top, you get 0.12 divided by the square root of, sorry, my pen is giving me problems now. The square root of 0.001428927. And if I take the square root of that answer, I get 0, so if I take the square root of this answer, so if I move this side now, so I have 0.12 divided by 0.037. So I need to take that and divide 0.12 divided by my 0.037801157 equals. And the answer I get here is equals 3, because we rounded off somewhere quickly. That's why we will get values that looks like this, 3,1745. 3,1745. It's because of some of the rounding off that we did so quickly that we lost some of the values. So probably the answer would have been option number 4. Any question? If there are no questions,
Ma'am,
Julia,
can I just find out
yes,
this exercise, if it happens that, like you said, it was one of the papers, if it happens like when you are calculating, like now we did, we see that we're not getting any like exact answer. So you just look at the closest one on the,
yes, you look at the closest one, but now you must be very careful because when you're calculating step by step, all these options here, they are the correct options, because if you look at the first one, it is part of the first, it was the point estimate. So if we use the point estimate one, we would have chosen that one. Like the other, and you can see that the next one, which is 0.014, it's almost exactly the same as that one. So if you don't pay attention to what you are doing, you will select the wrong one. The other lady said her answer was 0.037, which it is this one, which is not, because she didn't divide 0.12 by the value underneath. So she would have chosen option number 3. And then option number 5, it's part of the critical value. If this was a 5% level of significance, which then it means this is not correct. So the only option that is correct in this is this, but it means because they have rounded off, then they used all these values that they used to round off with. And they didn't round off correctly as well, because I can see here they have 8.6, which it should have been 8.7. And that is why their number is way too higher than ours as well, I think. So you can do the same, you can just double check and use, for the point estimate, use 0.486 instead of that long number. And for, actually, you don't even have to go there. You can just replace this, remove all the other digits and only leave it at 0.14 and say the square root 0.2, 0.12 divided by the square root of 0.0014. And the answer you get is 3.2071.
Yes, I see.
You see, so yeah, it's one of those. So you need to be very careful. You must just make sure that you double check that you did all the calculation right and you didn't round off quickly, and you make sure that you are at the end of your calculation before you make your decision. It is 10 to or 5 to now. I'm going to give you this one more exercise to do. And if you want to take a breather, you can take a breather. Then we'll come back at 6:05. At 6:05, we will then do this exercise and then continue with, let's make it 6:05. And then we will continue with the interval estimation. So do this one as an exercise. Remember point estimate. So this here is missing a 1. There should be a 1 there. Sorry, there is a 1 there. And remember for point estimate 1, it's x1 divided by n1. And for point estimate 2, it's x2 divided by n2. And the standard error, it is that square root of your point estimate times 1 minus the point estimate times 1 over n1 plus 1 over n2. That's the standard error. And remember that your point estimate is your x1 plus your x2 divided by n1 plus n2. What else? Your test statistic, it will be your Z-stat, which is your test statistic. You're going to calculate it using the Z-stat. Point estimate, proportion, sample proportion 1 minus sample proportion 2 divided by the standard error. And because you're doing a two-tailed test, you must be very careful because you need to go find Z alpha divided by 2. I will see you at 6:05. Are we back? How are we doing? Hello? No answer. Okay. Are you guys still here or you left? When I was working through this, I've noticed so many errors on this. The question actually is looking for which of the one of the following statement is correct. They are looking for the correct one, not for the incorrect one. So for number one, option one, how did you calculate it? It's x1 divided by n1. Our n1 is 150, and our x1 will be 40. So this would have been 40 divided by 150. Do you get the same?
Yes, I got the same.
And for the second one, it's 230. So this one should have been 30 divided by 200. What do you get?
0.15.
0.15. Therefore, this one is incorrect.
Incorrect. Yes.
Then we move to the next one, the point estimate. If we go and calculate the point estimate, is 40 plus 30 divided by 40 plus 30 divided by 150,
150
plus 200. What do you get?
Yes. 0.2.
You get 0.2, and then we come here, we substitute into this formula. It will be the square root of 0.2 times 1 minus 0.2. So I'm gonna run out of space there. Let's do it at the bottom. So this will be the square root of 0.2 times 1 minus 0.2 times 1 over 150 plus 1 over 200. When you calculate this, what do you get?
The end I get 0.0432 something. When I get the square root, that's a square root.
When you take the square root, what do you get?
0.0432 something.
0.04320 and some additional number. Yes. Therefore,
Yes.
it means this is incorrect, this is incorrect.
Yes.
And if we calculate the test statistic, our P1, we know that it is 0.2667 minus 0.15. Remember that is 0.15 divided by the standard error we just calculated. There was 0.042320 and some odd number. There will be 4937.
Yes.
Since now I have enough space, I can write all of them. And if you calculate this, what do you get?
I got 2.679 something.
When you calculate this, are you not putting it up? 0.2667 minus 0.15 equals 0.1167 divided by 0.0432 0.4937. I get 2.701. How many digits did you leave?
I left a lot. So it said 2.679. That's what I rounded off.
If you left a lot, you cannot get, because I left all of them. As you see them on there, I just calculated it. The answer I get is 0.2667 minus 0.15 equals 0.117. Divide that by 0.0423, wait, 4230. I wrote the number wrong. 0.2667 minus 0.15 equals, divide by 0.043204937 equals 0.701. 2.7011. Where did you get,
okay.
how did you get your 2.67? Are you forcing it to be 2.67? Did you calculate?
I suppose it's because of not taking all the numbers in, I keep on rounding off.
That is why I asked you, how many numbers did you round it off to in order for you to get the 2.6766? If you did round it off correctly, or if you did round it off, tell us so that we can try and see if we also get the same as what you have. How many number of digits did you leave it on? The bottom
Ms.
one.
Boy, I think that's 0.0423. Mine is 0.0432. Okay, let me just get that. I think the 23, mine is 32. I'm not sure if ever I made a mistake there.
Oh, it's
Because that's
320.
what I rounded.
No,
Sorry?
it's 0.043204937.
Yes, so for me, what I took was 0.0432. So I took only 4 digits instead of the rest of them. That's why I came to.
Yes, that
Yes.
is what I was asking. Let me calculate it.
Oh, I see. I made a mistake myself. It's 2.701 with 4 digits. Miss Pui, I can't hear you anymore. I'm not sure if ever somebody did mute, but I can see what you're doing, but I can't hear anything.
Sorry, I was saying,
yes.
if we read the question, it says it exceeds. So for the fact that it says it exceeds exceeds the proportion. Therefore, it means we're doing a one tail area, which is the greater than. Because of that exceeds, it's like when they say that the proportion or the proportion of success in population 1 exceeds the proportion in population 2. For this exceeds, it makes it a greater than, therefore it is a one-tail test, and it means we're not doing a two-tail, so we don't have two regions of rejection, we only need one region of rejection. And at 5%, I don't even have to go to the table to look for it because already this says two-tail. And because of this two-tail, I can just make an assumption that that one is also incorrect. It should be a one-tail test. And since we're doing a Z test, it means the assumption is that the population and the sample are normally distributed, because if the population is not normally distributed, we assume that our sample size will always be greater than 230 for the bigger sample size. And because of that, we assume that the population proportion will follow a normal distributed function. So number 4 is the only correct answer in this instance. I'm not sure where I got this question. I think I got it from your assignment. So you must check if I got it from your assignments. Your assignment should have had an errata somewhere, and they would have corrected some of these mistakes that they had. Okay.
Okay.
Let's look at how we do confidence intervals. Any question before I move to the confidence intervals? Any question?
Miss Boye, can you give me the previous slide, please, just before you move on? Thank you. Okay, thanks.
Okay, so let's look at confidence intervals. So with confidence intervals, since the confidence has the lower side, and also it has the upper side of the interval, and that is because of that plus or minus. So it means for the minus, we'll be calculating the lower side, and for the plus, we will be calculating the upper side. And sometimes in your book, I think they refer them to the lower confidence level and the upper confidence level. So they mean one and the same. So it means from this confidence interval question, we will you will calculate the upper tail area by using the minus, and you will calculate the upper tail area by using the plus sign, and which is given by the point estimate, which is, oh sorry, this must be P2, which is the point estimate P1 minus the point estimate P2, which is the difference between the sample proportions, plus or minus the critical value. Since because we're doing a confidence interval, the critical value will be alpha divided by 2 and times the standard error. And the standard error will be given by a point estimate for samples, the sample proportion 1 times 1 minus the sample proportion 1 divided by n plus 1 plus the sample proportion 2 times 1 minus the sample proportion 2 divided by n divided by n2. So let's look at how we do this calculation. So if we want to construct an interval, a confidence interval that lies between the proportion of men and the proportion of women, and we are given that 36 out of 72 will vote yes, and 31 out of 50 of women will vote yes. At 5% level of significance, we need to test this significance. So to do that, we're going to first calculate our point estimate 1, which is 36 divided by 72, which we did calculate earlier on in the previous exercise that we did with the hypothesis testing when we did the example. So it's 36 divided by 72 is equals to 0.5. And we also calculate the point estimate 2, which is given by your x2 divided by n2, which is 31 divided by 50. Which will be 31 divided by 50, which is equals to 0.62. And we can then substitute into the formula P1 minus P2 plus or minus our Z alpha divided by 2. And remember, we did find our critical value, which was alpha divided by 2 when we did the confidence interval. We'll come back to that just now. Times P1, 1. Let me do it on a blank screen, on a black screen. So I must write all these values that we have here. 36 over 72 is equals to 0.5, and 31 over 50 equals 0.62. Because I can see that I'm going to run out of space while I am trying to write here. So let's do this. We know that P1 is 0.5, and we know that P2 is 0.62. So now to substitute into the equation, plus or minus Z alpha divided by 2 times the standard error, which is sample proportion 1 times 1 minus the sample proportion 1 divided by N1 plus E2 times 1 minus E2 divided by N2. And we substitute into the formula. And substituting into the formula, we get P1 is 0.5 minus P2 of 0.62. Plus or minus, we did calculate our critical value. Remember, we found it was 1.96. So just use 1.96. When we go to the table, remember for the Z 0.025. And the critical value that we get from there is 1.96 times, I'm going to put this into bracket, the square root of, not the divide, times the square root of your P1 is 0.5 times 1 minus 0.5 divide by N. Our N is 72 plus 0.62, 0.62 times 1 minus 0.62 divided by our N was 50. So now we need to go and calculate all this and find the answer. So 1 minus 0.5 . 1 minus 0.5 equals 0.5 times 0.5 equals 0.25. Divide by 72 equals 0, I'm going to write it here at the bottom here, 0.00342 72222. How many twos? 4 twos. 4 twos, and we do the same with the other one. 1 minus 0.62 equals 0.38 times 0.62 equals 0.23. Divide that by 50 equals 0.004712. And I need to add 0.003471234 equals, and this gives me the square root of 0.008184222 times 1.96 plus or minus, and I can do the same, 0.5 minus 0.62 equals minus 0.12. Okay, so now I must multiply my square root of 0.0818422 times 1.96 equals plus or minus 0, I can split it actually from here without doing the plus or minus. So let's say from this side minus 0.12 minus 0.177314147, and on the other side minus 0.12 plus, because I'm just splitting it in terms of the plus or minus, 1.77314712. So there are a whole lot of numbers. So to find this value, okay, minus 0.1 minus 0.1 0.177314712 equals minus 0.2. This is minus 0.2. I'm going to leave it at 4 decimals. 2973, and on the upper side area minus 0.12 plus 0 point, so this should be 0 plus 0.2 0.17. I wrote this number this side wrong. So this is 0.01773 14712 equals. And on this side, it is 0.0573. And that is our LCL, and this side is our UCL, upper area. Any question? As you can see that your calculations are very time consuming. So you will have to make sure when you're doing the calculations that you are aware of what you are calculating so that you don't make any mistakes. Any question?
No questions, ma'am.
Okay, if there are no questions, remember I cannot come back to this screen. If I go out of this screen, this information disappears as well. Okay.
It's fine, ma'am. Thank you.
Okay.
All right. So with that, you have an exercise to do. I don't know what time is it now. Okay, you still have enough time. So calculate at 95% confidence interval. So it makes it easy at 95% confidence interval. Then your Z alpha divided by 2 is Z 0.05 divided by 2, which will give you your Z of 0.025, which is the same as what we have been calculating. So your critical value will be 1.96 for this. So you can use that critical value. So you will need to calculate the confidence interval, point estimate 1 minus point estimate 2. Plus or minus your Z alpha divided by 2. Point is proportion 1 times 1 minus proportion 2. Proportion 1, sorry, that's 1 minus proportion 1 divided by N1 plus proportion 2, 1 minus proportion 2 divided by N2. So find the confidence interval.
Okay, I'm done.
Okay, great. At least one person is done. Others? Other people?
Yes, ma'am, I'm also done.
Okay. So since you are done, those who are done, I'm going to ask you to give me the answers. I think today's session we're
Option
gonna
3.
go early. Do you all agree that it's option 3? Let's put in the missing parts. So P1, what did you get for P1?
P1 I got 0.5.
0.5 minus
0.6.
0.6.
Yes. Plus or minus 1.96. I gave you this.
Yes.
Times 0.5 times 1 minus 0.5 divide by 20 plus 0.6, 1 minus 0.6 divide by 30. I'm not going to ask you to do all the other calculations. You just give me the important values. So this is minus 0.1 plus or minus. When you calculate the whole right-hand side before the plus, after the plus or minus, what do you get? Sorry.
0.28062.
0.28062.
929.
So then they can work it out. And when you say 1 minus 1 plus that, it will give you minus. If you split it in terms of lower tail, you will say minus 0.1 minus 0.28062. There might be other values. And to get the upper tail area, you will say minus 0.1 plus 0.28062. And when you add them together, you will find those values that they all get, which is minus 0.3807 and minus 0.18. Any question? If anybody has any question, I got this from your first exam paper. So there are many other exercises that you can practice with. Okay, this looks exactly the same as what we just did. And this comes from your assignment as well. So if you look at this question, it says in your alternative, it's less than. So you must be very careful when you answer the question as well in your assignment, because in this, there is a combination. There is the hypothesis and there is also the confidence interval question. And with the confidence interval question, they assume that you already calculated this and they assume that this is correct. And they're asking you, is this, it's giving you that when you calculate the lower confidence level, and when you calculate the upper confidence level, do you get that? And you can verify that information because you are looking for the incorrect answer. The other thing is your region of rejection. Since you are only doing a left side, a one-sided test, and it's 90%, so your alpha will be 0.10. So you are going to use the right alpha value because this is 90%, which is 10% level of significance. And 10% level of significance divided by 100 is equal to 0.1. And if you look here, it says 0.01. You must remember this is part of the hypothesis testing. So this is only one-sided test. So your critical value this time is just be Z alpha. And if this is 90%, so therefore it means your Z should be 0.10. And you can see there it says 0.01, so you can make up your mind whether this is correct or incorrect. The test statistic, remember how you calculate your test statistic, your sample estimate difference, so your sample proportion 1 minus sample proportion 2 divided by the standard error. And the standard error, remember, it is different from the standard error of the confidence interval. Is where you use the square root of your point estimate, your pooled estimate times the square root of, your pooled estimate times 1 minus the pooled estimate times 1 over n2 plus 1 over n1, close bracket. So you must use the right test statistic. And then, since you know what your region of rejection will be, because you will go to the table, inside the table, you will look inside. Remember, you will go inside the table where you will look for 0.1010 or any value that is closer to that. And you can move out to get the critical value. And with that, if this is your test statistic and this is your critical value exactly as it's supposed to be, are you going to reject the null hypothesis? Then you make a decision. Remember, you're looking for the incorrect answer here. And then this is based on the confidence interval. So you can also use this, because if you are rejecting the null hypothesis, you can also claim that you cannot reject the null hypothesis, or you reject the null hypothesis based on that answer. And if it's based on the confidence interval, your confidence interval should include your population proportion estimates or your sample proportion estimates. Okay, and that concludes today's session. Just to recap on what we just did, we looked at how we form confidence interval for the difference between the two proportions, and we also performed a hypothesis testing for the two proportions. And that's all what we did today. So if you are not on WhatsApp as yet, you can join the WhatsApp group by clicking on that or going to that link, and it should give you access to the WhatsApp group. I will see you next week, Wednesday. Have a lovely evening. Unless if you have a question. Yes?
I just want to find out, how can I get your slides?
The slides are published. Where you find the link to the recording, there should be the link to the slides on the schedule. Are you on WhatsApp? If you are on WhatsApp, I will share the links with you on WhatsApp as well.
Okay, all right, thank you.
Remember, those who haven't completed the attendance register, please make sure before you leave, you complete the attendance register.
Okay.
Okay, and then please, before you leave as well, I'm going to post the link to the feedback form. So make sure that before you leave, you also complete the feedback form. If I can find the link. Please make sure that you complete the feedback form.
Okay.
I have posted the link on that is the attendance register link that I just posted. I'm going to post the link for the feedback form just now as well. Just give me a sec. I need to also stop the recording.